Good evening, everyone. My name is, as you can see on the screen, if you can see it, my name is Pillay, and I'm going to be running this program for the next 20 odd weeks. So you're going to see, or you're going to hear quite a lot of me. Let me just show you my face. This is me. I didn't comb my hair, but I hope you can recognize it if you see me in the mall at some time. All right, so I'm going to shut that off. Welcome to the first meeting of the Siyanqoba training program for seniors. I think you have been getting quite a lot of information about this program, and hopefully you are well acquainted with what it's all about. The main idea is to expose you to problems which are likely to occur in the national Olympiad competitions or any mathematics competitions, in particular the South African Mathematics Olympiad, which runs over 3 rounds. You've already taken part in the first round, and I am told that you are the people who have done very well in that exam, and I need to congratulate you that you have actually levitated to this level where you can get extra training and extra tuition. Now, a book has been sent to you. It's called the Siyanqoba, I think it's called Siyanqoba Problem Book 2025. And that book has got all the questions that we shall be discussing in the next 10 sessions. We've got 10 sessions over 20 weeks. So you can tackle those problems whenever you have the time, but we will do them systematically. And today we're going to do the problems of session 1. And then the next time we meet, we'll do session 2 and so on. So the idea in giving you the book in advance is so that you have a chance to read through the questions and make an attempt before you come into these sessions. Now, there's good reason to do that because there is no point in listening to the answer even before you've read the question. Mathematics doesn't work like that. You must always try it out, and then only will you qualify for the solution to be given. Now, the solutions that I give need not be the only ones, but if there are others, you can put that in the chat column, and then hopefully in the chat box, which is on the right-hand side, I think there is a little icon which says chat. You can put on your alternate suggestions, and at the end of the session, if we've got time, we will quickly look at that and add that to our list of solutions. So with that, I just want to share with you you see, each session has got one assignment, and you will have an assignment sheet which is given to you. David, have we given the assignment sheets already?
Yes, because it's inside the booklet.
Oh, okay.
Yes.
What page is it? Is it towards the end, David?
Yes.
All right. So if you open to your booklet, you don't have to do that now, and go to the end, you will see assignment problems. And the very first problem, there will be the problem which I think there are 10 problems. So those 10 problems are referring to the 10 problems for each session. So today you will have to do problem 1 in session from this session. That's the first problem. You have only one problem to do each week. David, do you want to say something about that? How they have to submit the problems?
Okay. The center managers will communicate with each learner. It will be based on the area. They will tell them where to submit the assignment, and then they will send them assignments.
Okay. I faltered here. I should have introduced you to my good friend from the South African Maths Foundation. He's right at the top right, if he's on your screen. His name is David Ramaboka, and he's been assisted by, um, please give me his name.
It's Khotso Matseke.
Oh, it's Koso Maseka. Koso,
Yeah.
have you shown your picture there at the top right? Okay, I don't think he's doing that, but there's somebody else who's got the video on. David, can you just ask the person to...
Khotso.
Right. Imanga, I think he had... Imanga, can you please take your video off, switch it off, in the bottom left-hand corner? All right. So I think without much further ado, we will go straight to the problems that we are going to do today. Let me just share the screen with you. If I'm a little bit shaky on this, forgive me, because I'm not very good in all these technological things. David, I'm trying to share, but it's not coming on. I wonder why.
I can see you shared something on the screen. Oh,
I'm taking
you
it
can
off now.
just
But I can't
reshare.
see it. Yeah,
Just
hold
share
on.
again. It's now out.
Okay, I've got it. All right.
Yes.
Okay, the date is supposed to be 9th of June, and I got 2nd of June because we were supposed to start last week. All right, so let's go to the first problem. Hopefully, you had some time to have a look at these problems. So I'm going to go straight into the question. A set of 12 numbers has average 18, but the smallest and the largest have average 28. What is the average of the others? Okay, so now let's first see what you mean by average. You've learned how to calculate averages at different times and in your early days. So we'll just recall that. And by average, you mean, how do you calculate the average? If I say, what is the average of 3, 9, and 11 or 12, then you add them and divide by the number. There are 3 numbers. Yeah. And that will give you the average. So the average is equal to the sum of the numbers. I must apologize for the poor writing. Divided by the number of, the symbol here is number of numbers in the set. So that is what you mean by average. All right. Now, often we use often we use a slight variation of this, and that is, if average is the sum of the numbers divided by the number of numbers, then it's the same as saying that the sum of the numbers is equal to the average, let's call it A, times N. So if we use the sum as S for sum, and this, the number of numbers is N, then you got A for average. A is equal to S over N. So therefore, S is equal to A times N. In other words, if you add up all the numbers, you're going to get the average multiplied by the number of numbers. Now, this is very important because we are going to use, I think that this question comes up a couple of times. So always remember that the average multiplied by the number of numbers is equal to the sum of all the numbers. So if you look at this now, a set of numbers, 12 numbers, so you got n as average 18, right? So you got the average and you got this, so you can work out the sum. So the sum of all the numbers, of all 12 numbers, is equal to the average multiplied by 12, right? Because average times, and that is 216. Now, the smallest and the largest have got average 28. So the sum of the smallest and largest is equal to, there are only two numbers there. So it's the average of those two is 28 times 2, and that is 56. Okay, so the question is, what is the average of the others? So, in other words, there are 10 left. So the remaining 10, right, you need to work out what is the average. The question is, always bear in mind what the question is. What is the average of the 10 numbers? That is the question, right? Now, if you know the sum of all the 12 numbers, and if you know the sum of the two of these numbers, then we know what the sum of the 10 numbers is. The sum of the remaining 10 is just the difference. So we know that the sum of the remaining numbers is just the difference between those two, because this is a sum of all 12 and this is a sum of only 2. So the remaining 10 is that. But now you've got the sum and you got the remaining 10. So therefore you can work out the average. So the average that we're looking for is the sum of all the numbers, which is 160. Anyway, you know that. How to find the average? You just add up everything. This is the sum of the whole lot. And how many are there? There are 10. And the answer is 16. All right, so this is a sort of problem involving averages, and it's not very difficult, but just you have to just remember these two facts. All right, so let's go on. You'll notice that I won't ask you for your opinions or anything like that, but every now and then I'll ask you if you have any questions and we can address them. All right, I'm gonna go on to the next question now. The first one was somewhat straightforward. Okay, I'm going to take this and so the next question is, a certain value increases by 10%, no, by a fixed amount each year, right? So if the percentage increase is during the first year was 10%, what was the percentage increase during the third year? All right, let's try to understand it. The first year there was a percentage increase, and the second year we don't know what it was, but you do know that the amount increases by a fixed amount. Now, can we calculate what that fixed amount is? Well, let's just first just talk about increase in percentages. Now, what I'm going to tell you is quite important, because this particular fact is going to be come back many times in your school career, especially when you go to grade 11 and grade 12. So if you understand this, you'll be well on your way to understanding the mathematics of finance, which comes much later. Now, how do you work out a percentage increase? If I ask you, what is, like if I say increase, say 60 by 5%, right? How do you do that? Well, you will say, if I want to increase 60 by 5%, so I have to add something to this number. What do I add? I add 5% of 60. So the actual increase is 5% of 60. And the way to do that is 5% is 5 over 100 times 60. I always like to write it like this. I put 5 times 60 over 100, like that. So because this is 60 over 1. So when you multiply two fractions, you multiply the numerators and multiply the denominators. So then you cancel now. 5, 10, divide by 10 on both sides. So you just cancel the zeros. Then 5 goes into 10 2 times. And 2 goes into 6 3 times. So this is 3. So the actual increase is 3. 5% of 60. I've just calculated it. The faster way is 5% is 1 over 20, 1/20th. And 1/20th of 60 is 3. But in general, this is what you do. You put 5 over 100 times that times the number itself. So if you had generally, so this is your actual increase. So the question has increased 60 by 5%. So the new number is the original plus the increase. Right? That is how you calculate a percentage increase. So if you increase 60 by 5%, it comes to 63. Now, I just want to, I'm doing all this because I want to make it abstract now. In other words, I'm going to say, if I say increase a number A by, say, R%, exactly the same problem. It's just that you've got a symbol instead of numbers, right? And if you see what we did here, the first thing we do is we work out R% of A. And to do that, the way we did this was we put R over 100 times A. So that is R A over 100. This is A over 1. R times A is RA. That is how you write on a product in symbols. You put them next to each other. All right, and then if you want to get the actual, the final, if you like the final number, not the best way to describe it, but it will be your original, which is A plus RA over 100. That was the increase. That is the 3. And here,
Sorry, Prof.
yes.
Learners can't hear you.
Oh, they can't hear me. Oh,
Yes.
why are you telling me so late? Is my mic off or what?
I can hear you on my side. I don't know about them.
Oh, I see.
I can hear you too. I am a trainer.
Can we just have by show of hands how many people can hear me? Just use your host tools or something. Yashin is only okay. There are others who can hear me. So there are a few people who can hear me. The problem, I guess, is with that. I can't solve that problem. It's something what they are doing. Ask them to put their audio on. You see, there's audio on the left hand side, a little symbol which looks like a microphone. If there's a cross across it, if If it's crossed out, then it's muted. But tap it, and the cross will go away, and then you can hear me. Hopefully that'll solve the problem. Okay, so
Yes, Prof. Yes, Prof. Or they can go out, and then when they click the link again, they must join with the audio on. If they can join while the audio is not on, they won't be able to hear you.
Oh, I see. All right, so
Yeah.
so you can handle that. Okay, let them go out, exit, and come back, and make sure your audio, which is the little microphone on the left-hand side, has got no crossing. It's not crossed out.
We cannot hear you.
You still cannot hear me. Okay, I can't do much about that because most of the people can. So it seems to me that the problem is on your side. I'm sorry, I'm struggling a little bit to get back. Okay, so I think this is where we are. So the final number, can you see the screen? Hello?
Yes, Prof.
Yes.
Yes, we can.
All right, okay. So the final number is A plus RA over 100, and that is the same as, you can take the A out. I'm sorry, I'm squeezing you up for time, for space. Oh God, this is something. It's going to be, if you take the A out as a common factor, then A goes into this one time, plus A goes into this R over 100 times. So that is how you increase by R percent. So to increase by R percent, you add 1 plus R over 100 times your original amount. If you want to decrease it, then it becomes 1 minus R over 100 times the original amount. Okay? So bearing that in mind, then we go back to our this question itself. So what is it saying? It says that you've got a number which increases by 10%, by 10% the first year. All right, the number is not given. So why, in a situation like that, you can put your own number and then see what happens. So if I put my own number, a nice number to use if you're using percentages, is suppose then the value, is 100.
Professor?
It increased by a fixed amount, and the percentage increase in the first year was 10%. Right? So 10% of this is
We
10.
can't see the we can't see the writing, sir.
Oh, you can't see the writing?
Yes,
Oh,
sir.
okay, then I'll try to make it a little bit bigger. Okay, so 10% of 100 is 10. So the actual increase now, we say it increases by a fixed amount. So the first year the increase was 10. So the increase is 10. Can you see it now? The increase is 10. So in the first year, it went from 100. Right? After the first year, it came to 110. Then it's a fixed amount, so 120, and then 130. So the question is, what is the percentage increase during the third year? This is the first year, the second year, and this is the third year. So the actual increase, the percentage increases, it increased from 120 to 130 in the third year. So we need to calculate what the actual increase was first. The increase was 10. So then we calculated that in the third year, we would have got 130. And what is the percentage increase during this time? So percentage increase David.
Yes, I'm
Okay,
here.
so-
Please, everyone,
Yeah,
please
do me a favor.
mute
Can you
yourself.
mute everybody
Can
else?
you mute
Mute
yourself,
everybody else.
or we'll mute everyone, please?
Yeah, please.
Can you mute yourself, please?
If you can do it centrally, it'll be much better because there are people who are talking in. Percentage increase will be from 120 to 130. The actual increase is 10, but over 120. This is the original, and this is the final, right? So the actual percentage increase will be 10 over 120 times 100 over 1. See? Okay, so if you do this the way I told you, 10 times this, this 10s cancel, and you got 100 over 12. So simplify this, 4 goes into this 3 times, 4 goes into this 25 times, and it's 25 over 3, which is 8 1/3%. You'll notice I do all my work in fractions, all my calculations, because it makes it very, very much easier. You must try to learn how to do it like that also, because then you can cancel and you can do things with that to simplify your calculation. So you can see how quickly I've got to this by just deleting common factors. 25 over 3, that's easy, 8 1/3. Okay, I think I need to go a little bit faster now because it's still got many more to do. Okay, so let me get to this problem number 3. So problem number 3 says, what is the value of square root of, you got this rather cumbersome object here. There's supposed to be a bracket here, I think. All right. Now, you might wonder why are they speaking about square roots here? This is really testing something. Now, if I ask you what is the square root of 5 squared, right? So if you do it the long way, you'll say this is the square root of 25, and the square root of 25 is 5. Right? So if you say what is the square root of x squared, you will be tempted to say x. Right? I think 99% of people will say the square root of x squared is x. And the fact of the matter is, this is not the correct answer. I'll tell you why. Because suppose I wrote down square root of minus negative 5 squared. Then if you work this out, it's square root of negative 5 all squared is 25. And when you write down square root of a number, you always take the positive value. So this is 5. The square root of negative 5 squared is 5. It's not negative 5. So you can't put square root of x squared is x. See? Because this is true if x is positive. But if x is negative, this is your x. whatever you're squaring. If it's negative, the answer is not x, it's minus x. See? So you have to see what is being squared. If it's a negative quantity, you have to change the sign of that. That is the thing. So in this particular problem here, you will, this whole idea comes in. So just remember, the square root of x squared is either x or negative x, depending on the x itself. If x is positive, then it's x. If x is negative, it's negative x. So just bear that in mind. So now you got the square root. Let's work out these two things. Samsung SM, raise your hand. I told you, don't ask me questions now. At some point, I will ask you what your questions are. All right. Okay, but at least you reminded me that I should do that. Now, we got two square roots. I got a square root of 20 minus 21 all squared. So here you've got a square root of a number which is squared. And as I said, you'll be tempted to write down this is square root of 20 minus square root of 21. But you have to check to see whether this is a positive number or a negative number. The square root of 20 is about 4 something. So you got 4 minus 21. So this thing here, this is some number which is smaller than 21. If you're subtracting that, this number is negative. So the square root of this is not square root of 20 minus 21, as you might expect, but it is minus of that. See? Because this number here is negative. So this part here is minus of this. So I can simplify this. This is minus square root of 20 plus 21. Right? If you expand this. Now here, both of these numbers are positive. Both these numbers are positive. So therefore, you got the square root of a positive number squared. So here, it's fine. The square root of that is square root of 20 plus 21. See? Now when you simplify this, you get minus the square root of 20 plus the square root of 20. So you get 21 plus 21. So the answer is 42. Okay, so this just is a test to see whether you know what the square root of a number squared is, right? And one has to be very cautious when it comes to that. That is what I was saying. Okay, this whole session, like all the sessions, will be recorded. David, you want to say something about that?
Hi, Prof.
Yeah, tell them about the recording.
Yes, this session is recorded, and then we will share the recording with the center managers and also with the learners. The link. There's a YouTube link.
So the center managers will share that with all the students.
Yes, we can even
if it's possible.
to the students.
Yeah, because not everybody can take a recording and put it onto their phone, because the recording takes on a lot of data. All right.
Now put it as a
center
link.
manager. Yeah. All right. Just a link. Okay. Oh yeah, it's a link, so you can go into internet. Okay. After this point here, now, are there any questions? Any comments? All right. So nobody seems to have any comments, so we can proceed. So let me get on to the next question. The next question is, for how many positive integers k does the equation, we finished with averages now, and the early part. For how many positive integers k does the equation kx minus 12 equals 3k have an integer solution for x? So So let's understand this question. For how many positive integers k does this thing have an integer solution for x? So let's try some things. Suppose we try, just to understand the question, if k equals 1, just one moment, I'm trying to do something on my screen. It's got a little box here and I want to try to take it out. And normally there's a way to do it, but it doesn't seem to be working. David, I think there's 5 people who are waiting in the waiting room. Can you just let them in? David, can you hear me?
Yes, Prof, I'm on that.
All right, there are 5 people who are waiting in the waiting room. Okay, so for how many positive integers does this equation have a solution? So what we are going to do is just try. So say k equals 1. Okay, so if k equals 1, you've got x minus 12 equals 3. When you solve for x, you got 15. And that is an integer. So there is an integer solution for k equals 1. So k equals 1 is one of the values for k. If you try k equals, for instance, 5, right? K equals 5. Then you got 5x minus 12 equals 3 times 5 is 15. And then you'll have, bring all the x's to one side, 5x equals 12 plus 15. That's 27. Okay, 5x equals 27. X is not an integer. It's 5,4. So 5 is not a solution. So in other words, there are some values of k which gives you an integer solution, and the other values which don't give you an integer solution. So the question is, which values give you the integer solution? All right. Just as a digression, I must apologize. I thought I was speaking to juniors and I was taking my own sweet time. I'm actually speaking to seniors, so I'm going to start moving it up here a little bit. Okay. I'm quite confused about all this. In fact, I thought this class is for juniors. That is why I came in a little bit late. Okay, let's solve this. Now, you know, kx minus 12. I'm going to solve for k. So, so you got k. If you bring all the x's to one side, kx equals to 12 plus 3k. And therefore, x is equal to 12. We want to find the solutions, integer solutions. So I'm going to solve for x. So x is equal to 12 plus 3k divided by k. Now this is the same as 12 over k. If you split it up, plus 3k over k. So this is 12 over k plus 3. Right? Now what I've used here is a very important fact here. A plus b over c. Very often you use this fact here. It's a over c plus b over c. Because if you simplify this, you're going to get that. But watch out, you can't do anything with c over a plus b. This thing here, it cannot be simplified. See? if the denominator is a plus b, if the numerator is that. So this is what we've done here. So now we want to know for which values of k is this thing here an integer? Because that's your value for x, you see. You want x to be an integer. Now 3 is already an integer. Okay. So for this whole thing to be an integer, 12 over k is an integer. So we need to find out for which values of k is this an integer. So what do you mean by that? Earlier on, we had, I think I took an example here which I've deleted. I had something like 27 over 5. And that was, we deleted the one because this is not an integer. Why? Because 5 does not go exactly into 27. If it goes exactly into 27, then this thing here is an integer. Like in this case here, you got an integer solution. So because 5 does not go exactly into 27, this is not integer. So to make this integer, that means k goes exactly into 12. Therefore, k is a factor of 12. Now that is powerful. And now that you can calculate. You can calculate all the factors of 12. That's easy. I'm not going to do it because you can see how you can write down all the factors, and you need to know how many positive. Oh yes, you need positive integers. That's quite important because the factors of 12, you can have negative factors as well. You can write factors of 12 is 1 times 12, 1, 12, 2 times 6, 2, 6, 3 times 4, 3, 4, and that's it. When you come to 4, you already got 4 times 3. Right? So these are the 6 positive factors. But remember, even negative 1 is an integer is it allows for negative numbers, you see. So I could have put negative in front here and you'll still be okay because k will be a negative integer. But they say here that k is a positive integer. So you only have to look at these. So I can see that there are 6 solutions. The answer is there are 6 positive values which will make this thing work. So we tried k equals 1, it worked, you see. That's one of them. And the other ones which have worked would have been these. Right. You'll notice 5 is not one of them. Right? That didn't work. Okay, so let's just get on to the next problem. This is a new idea here in this particular problem where we have a fraction and you want to know for which values this thing is an integer. So remember, I just want you to bear this in mind. This will be an integer provided k is a factor of the numerator. Right? In this particular case, the 3, we can take out 3, so you need to worry about whether k is a factor of 12. Right? It's a very important factor. Bear that in mind because it's the kind of thing that comes out in problems. Okay, so the next question here is, okay, now this question here says, in the equation ye times me equals ttt, each of the letters represents a different digit from this set. So they're all different. So y, m, e, and t are all coming from the set here. So in other words, it's a 2-digit number. But it could be a 1-digit number because, oh, okay, all right. It's a 2. These are all they are digits. So now the question is now, what is the values? What are the possible values for y, m, e, and t? And in the end, you have to calculate the sum of those 4. So we need to solve for y, e, m, and t. Now, how do you do this? Because there's no symbol. So let's just try to see what we've got here. We've got a product of 2 numbers. Equals t, t, t. All right. So what we've got here is that this The second digit is the same in both cases. The second digit is the same in both cases. Now, I want to look at this number here. You see, like TTT could be 111 or 222 or 333. It's of that type, going all the way up to 999. So we don't know what this is, but we can see clearly that this is 2 times 111. This is 3 times 111. And this is 9 times 111, which means that this is really T multiplied by 111. If you write this thing out in full. Now this is a 3-digit number. Now you got two 2-digit numbers being multiplied. So let's see whether we can factorize this. The 111 is also T times, if you add the digits, it's 3, so 3 is a factor, and 3 goes into this 37 times. So you got that YE times ME equals T times 3 times 37. So we can say 3T times 37. T is a single digit, so this is 3 times a single digit, so this is also a 2-digit number. Right? Depending on what the value of T is, right? It's either 31 or 32 or whatever it is. There are so many possible values for T as we saw here. But remember that the E's are the same, you see. So this is 7. So 3T, this thing here, this is 3 times T, ends in 7. And this is a very important fact because 37 is going to be one of the factors. So this is 37 times YE. So YE will be Y7 because you got that. But now we know that this number here is 3 multiplied by T. So 3 times what ends in 7? So the answer is 3 times 9 is 27. So 3 times what ends in 27? So T must be 9. So we got T equals 9. And you got E is equal to 7. Right? Because those are the same there. And the only other thing that is left is M. M is that one. And we saw that it's going to be 3. So we got T, E, and M. We don't have Y. Where did Y come from? Oh, Y is this. So now you've got T is 9, you see. So you got Y7 times 37. Or actually, 3T is 27. So Y must be 2, you see. This part here is 27. So Y is 2. Because now you got 37 times 27. And that will give you 999 because T is 9. So if you check it out, you'll see that 37 times 27, actually I'll get it like this. 27 times 37 equals 989 if you check it out. Right? So therefore you got your Y and you got your E and so on, and you can add all of them up to get the answer, which I'm not going to do. There are 4 numbers there which you can add. Okay, so that finishes the next question. And I now want to go into this question here. If M and N are both odd integers, then which of the following numbers must be even? So M and N are odd integers, both are odd numbers. Which of them, the following numbers must be even? Now for this thing here, I need to just analyze what happens when multiply odd two numbers, and when you add two numbers, which could be even or odd, right? So I'm going to just look at some rules here, right? Now, let me open it out. You guys can speak if you want to. You can open your mics, just for now, and somebody can tell me what happens. If you got even, I'm going to use the symbol E for even. If you got even plus even, odd plus odd, O for odd, even plus odd, or you have even times even, or you have even times odd, or you have odd times odd. Now, in each of these cases, you can decide whether it's going to be even or, okay, you don't put the equal sign. Now, if you add two even numbers, you get an even number or an odd number?
Even number.
Even number.
Correct, right. Odd plus odd?
Even number.
Even number, right? 7 plus 7 is 14, because it's twice that. Even plus odd?
Odd number.
It will be odd, right? Even plus odd is odd.
Yes.
Right. But now, okay, we finished with all the sums. Now, if you take even times even, obviously it's
Even. Even.
And even times odd?
Even.
Yeah, this is even. Even times an odd number is even. And an odd times odd is?
Even. Even number.
Oh, times odd.
Odd
3
number.
times 7.
Even number.
Yeah, this is an odd number.
Odd number.
An odd number times an odd number will be an odd number. Okay?
Yes.
So you have to know all these to answer this question here. Now you got M and N are both odd. So both of them are odd. Right. M times N, odd or even?
And
Both M and N are odd. It's odd, right? Because it's, you go to this one. Right here, you got M and N are odd. So you got odd times odd times odd. So this whole thing will be odd, right? When you got an odd number and you add 2 to it.
Odd number. Odd.
Yeah, because an odd number, you're adding an even number to it. So it's going to be odd again, right? And here you got both of them are odd. So what is M plus N? Even or odd?
Even. Odd.
Even, right? Yeah, because even both of them are odd. Odd plus odd is even.
Yes.
So you get an even number, and if you increase an even number by 1,
yes.
you're going to get odd, right?
Yes.
So that is odd. Now here,
Odd
this is
number.
2M is always even, right? Because you're multiplying by 2. So here you got an even, and here you got 3 times an odd number. So you got an even, 3 times odd number is odd, and 5 is odd. So you get even plus odd plus odd. These two odds will give you an even. So it's even plus even. So this is even.
Even number.
Okay? And here you got there's an even here, and you're adding an odd number. So you're going to get an even plus an odd is odd. So, this is just giving you some exercises on how to deal with even numbers and odd numbers. You speak about the word parity, Parity. Go and Google it and you will see what it means. Parity means when you speak about a number, if I say, what is the parity of 27? And you will say odd. In other words, the parity is asking, is it odd or even? What is the parity of 6? What's the answer?
Even.
Even, yeah. So the word parity is used to describe an evenness or an oddness. Okay, so let's now look at the next question. The next question is, a certain country has coins having values 1, 3, 5, 1, 3, or 5 cents. So this country has got, their coins are, got 3 types of coins. This is a 1 cent coin, and this is a 3 cent coin, and this is a 5 cent coin. Now, can one make a change of a 25 cent coin? Right? You're going to make a change of it using all the 10 coins. Right? Each having the value 1, 3, or 5. So you've got a number of 1s, a number of 3s, and a number of 5s using those, and you're going to get all that is going to add up to 25 cents. And the question is, you got 10 coins. Question is it possible to do that? I'll leave that open. You can just think about it. You got 10 coins. Yes. Rico, you want to contribute to that? What's your answer? Okay, I think Siyanqoba wants to say something. All right, look, okay, let me tell you then. So you got 10 numbers. They are either 1, 3, or 5. So you got 1, 3, 5, 1, 1, 1, but you got 10 of them. I don't know you. Maybe you got 1, 2, 3s and 1, 5 or whatever, right? You got 10 of them. When you add up all these numbers, can you get 25? The answer is no. You know why? Because you can group these 10 numbers into pairs. 1 plus 3. So you can get 5 pairs. Sorry, this is looking very bad here. Right? And each pair is a sum of 2 odd numbers. So you got each pair, you add up to an even number. So you got 5 pairs, each one is an even number. So if you're adding 5 even numbers, your final answer will be even. Can't be 25. Right? And this is a good example of problem solving. See? Where you got no formula or anything like that. You're using common sense. You got 10 odd numbers. It's the same as saying 5 even numbers. Because if you pair off those 10 odd numbers into groups of 2, then each one of them is even. So you got 5 even numbers. When you add them, you're going to get an even number. You can never get 25. So the answer to this is no. Right? If I asked you this question in your assignment and you say no, we'll give you 1 mark out of 10. Because you only got 2 choices, either yes or no. You'll have to explain. You'll have to explain why it is no. Then you'll get that other remaining 9 marks. See? So there's a lot of in mathematics,
you're
you are
basically,
often asked.
so
Nasra, you
you're
got,
basically,
I'm
so
sorry.
you're basically stating that if we like answer a certain question, we have to give a valid reason.
Yes, otherwise it's just a guess. Right. We're not testing whether people can guess correctly or not. We're not seeing whether God is helping the person or not. You must see whether you yourself can answer that question. And you have to give a reason. Even in our assignments now, the assignments don't just write down an answer. You will only get 1 or 2 marks. But you have to explain why you are getting that mark. Do the calculations and show us what you are doing. Right? It's a good thing this thing was raised. In all your assignments, you have to explain how you're getting the answers. You might have a problem explaining, but you must read your own explanation and ask yourself, if I'm somebody else and I'm reading this, would I be able to understand what this person is saying? That is a way to check to see whether what you're writing is correct or not. All right, so you must explain. Okay, so the next one is, you see, this is not multiple choice. Multiple choice, people can just take guesses. They'll ring E or ring A or ring C, without even knowing why they're ringing it. But some people calculate it and they know why they are doing it. But others might not. They'll say, okay, I just hope that I'll get it right. We don't work like that in problem solving. Okay, so let's just go to the next question. David, there are still 2 people waiting in the waiting room. I thought they came in so late. Okay, so the next question is, let n be a natural number. If the tens digit of n squared is 3, then what is the last digit of n squared? All right. So the tens digit is 3. What is the last digit of n squared? Okay, now this one here is not an easy question, right? It's a difficult question, but I'm going to give you a way of solving this problem. Okay, just ignore this table here for the moment. Tens digit of n squared. So you're squaring a number, all right? And if you want, you can try 11 squared. Oh, God. 11 squared is 121, right? But the tens digit here is 2, right? So you need to know what the this number is. Now this is a natural number, so you could have had 5193672 squared, right? And then you got some huge number here, but the tens digit is 3. All you know is what is the second last digit. You know that. We don't know what the other ones are. So they ask you, what is the last digit? What is that digit going to be? Okay. So it looks like a difficult question, which it is. What I want to say here now, this is quite important. When you're squaring a number, and if you didn't know this little thing, you'll never be able to get the answer to this. If you're squaring a number, I want to see what happens. Right, when we square a number, it can be an even number or an odd number. Right? So if you take an even number, say 2m, even number can be written as 2 times something. Right? And an even number, if you square it, you get 4m squared. I'll repeat that. If you square an even number, a square of an even number. Now this number here is interesting. It's a multiple of 4. So the square of an even number is a multiple of 4. It's 4 times something, an integer. See, m is an integer, so m squared is an integer. So 4 times an integer is a multiple of 4. But if you square an odd number, an odd number is an even number plus 1. 1 more than an even number. So an odd number will look like this. So I've finished with even numbers. I'll take a random odd number. It's going to look like this. And when I square it, now you can square this thing as 4m squared plus 4m plus 1. You learned about this, how to expand a binomial. So this is 4m squared plus 4m plus 1. This part here is a multiple of 4. Because 4 into m squared plus m. So this is 1 more than a multiple of 4. Sorry, 1 more than a multiple. Sorry, my writing is putrid. I have an excuse. I'm left-handed, you see, so it's very difficult to write on this number pad here, left-handed, so that it becomes legible. This is one more than a multiple of 4. So in short, a square number is either a multiple of 4 or one more than a multiple of 4. So I'm going to write this down. A square number is either a multiple of 4 or one more than a multiple of 4. Now, interestingly, when you say one more than a multiple of 4, it means it's 4 times something plus 1. Right? One more than a multiple of 4.
So, sir, isn't the last digit going to be 9?
Nasra, can you ask me these questions after I finish? I mentioned earlier on, I think you guys came late. To everybody, you can ask your question when I give you a chance to ask the question. You can put it down on your page there and keep it in abeyance. I've got 40 odd students. If I start answering questions to everybody, I'll never be able to move on. Okay, that is the reason, not because I'm unwilling to. So you can ask me that question later on, and then I'll tell you whether you're right, or if you're wrong, I'll tell you why. Well, the reason for it. Okay, now I was saying right before I was disturbed that one more than a multiple of 4 is the same as saying that when you divide that number by 4, the remainder is 1. Take 25, for instance. 25 is 1 more than 24. Right? 24 plus 1. So when you divide 25 by 4, the remainder is 1. Goes into 6 times, the remainder. We're just worrying about the remainder. So the remainder must be 1. So now the question is now, what is the last digit? The last digit, that is the question. Now this is where this table comes in. But before we get to the table, how do you decide whether a number is a multiple of 4 or not? Anybody can answer that. Rules for divisibility by 4. All right. You should know all the rules. And if you don't, go and check it out, because I've got no time to go through that. You've already passed your first round. All the rules for divisibility by 2, 3, 4, 5, 6, not 7, 8, 9. All the numbers, you should be able to very quickly decide whether 9 goes exactly into a number, or whether 3 goes exactly into a number, or 4 goes exactly into the number without having to do long division. These are called rules for divisibility by 4. If you got the book that I've written, it's called, I don't know, David, you want to say something about the book?
It's 1000 mathematics problem. I will
Yeah,
refer
Maths
to it,
Olympiad.
Prof.
Yeah.
Yeah.
Are they going to get a copy, or is there any? No.
Yes, we will discuss it, Prof.
Okay. So
Okay.
if you do get that book, it's a very big book, 643 pages, which I wrote. There's a whole section on rules for divisibility by 4. But I think by now you already know that the rules for divisibility by 4 is the last 2 digits must be a multiple of 4. So if you look at these here, the last 2 digits, 30 is not a multiple of 4. So that's out. It's either is a multiple of 4 or multiple of 4 plus 1. So the red one, this is a multiple of 4. And here, this is a multiple of 4 plus 1. Here too, you got a multiple of 4, and multiple of 4 plus 1. The other ones are not multiples of 4. You can see the remainders are 2 or 3. But we are interested in those. Multiples of 4 give you a remainder of 0. Multiple of 4 plus 1 gives you a remainder of 1. So when you divide these numbers here by 4, you're going to get the remainder 0, or this thing here will give you a remainder of, it's ending in 2 plus 1, so the remainder will give you 1. Okay, so your last digits is one of these, 2, 3, 6, or 7. See? Now, so n squared ends in 32, 33, 36, or 37. Those are the only ones which give you a multiple of 4 or multiple of 4 plus 1. Now, the second important fact here is that a square number, if you've got a square number, what does it end in? Now, a square number, take any number, and it could end in any one of these. The number itself. This is your ending. Four, 5, 6, 7, 8, 9. Now, when you square it, what is the ending? When you square a number ending in 0, it ends in 0. Right? Anything, so something times 1, 41 times 41 must end in 1. If it's 42 times 42, it'll end in 4. 43 times 2, 43, 3 times 3 ends in 9. 4 times 4 ends in 6. 5 times 5 ends in 5. 6 times 6 ends in 6. 7 times 7 ends in 9. And 8 times 8 is 64, ends in 4. 9 times 9 is 81. So the square number n squared ends in either 0 or 1 or 4 or 9 or 6 or 5. 1, 4, 9, 0, 1, 4, 9, 6, 5. And all these are repeated here. So a square number will only end in these. Right? If you take any number and you square it, it'll end in one of these. So this number is a square number, and it must end in one of these. Now you can see it can't be 32. The square number can't be 32 because it doesn't end. Can't be that, and it can't be that, because it must end only in one of these. So therefore, the only survivor is 36. So the answer is 36. The last digit is 6. Now this is quite a deep problem involving a lot of important ideas, right? And when you get the recording, go over this very slowly and try to understand exactly what I have said. Right? The recording will come to you in the form of a link. So you just click on the link and you will get the entire recording. Okay, so a couple of important facts here is that when you square a number, it is either a multiple of 4, if the number was even, or it's a multiple of 4 plus 1. That is if the number was odd. Right. And then second thing, the square number can't end in any possible number. There are only 6 possible endings for a square number. And those 6 numbers are these: 0, 1, 4, 9, 6, 5. Okay, so let me just go on to the next question. Okay, this one here, I'll deal with this quickly. I'm running out of time now. And how many solutions are there for the equation x squared plus 125y cubed plus 2017? How many integers satisfy this? So in other words, I'm going to put an integer here, square it, put an integer for y, cube it, multiply by 125, subtract those two, and see whether the answer is 2017. It looks like an impossible to get the answer. A lot of people will say, no, but it's impossible. How do you know? How can I have to substitute so many numbers and and subtract and see whether I get 2017. No dice. But you can do it. This is how you do it. If you involve the same thing that I just told you, you got a square number here, x squared. Leave it on one side and take the remaining part, take it to the other side. And I got x squared is going to be this. So now you can work out the endings of this number, right? And see whether it is one of these. 0, 1, 4, 5, 6, 9. These are the 6 numbers that we had before. Now we already know this number ends in 7. We'd like to know what this number ends in, so that when we add these two, I want to see whether I'm going to get one of these answers. Right, I'm going to repeat what I've just said. I need to know what the ending of x squared is, right? I want to see whether it's going to be one of these. I already know it's 2017 plus something. And the something here is 125y cubed. And I want to see what this final digit is, right? Now, so at this stage, you'll say, well, I don't know what y is. Y can be anything whatsoever. But we can do what we said earlier on and say if y is even, right, then y is equal to 2 times something. Call it 2 times k. And then we got x squared is equal to 125 times y cubed. Now y cubed, if y is 2k, it's 8k cubed plus 2017. Now, 125 times 8k cubed is really 1000 k cubed. So 125 times 8 is 1000 times k cubed. Now, if you got a number which is 1000 k cubed, it ends in 000, you see? Because 1000 times any number, we don't know what the other stuff is in the front, but this number here, if k is even, this number is a multiple of 1000. And now when you add this, your ending is 7. So it doesn't work. If y is even, this is not a square. So if y is even, no solution. Because now this number here will end in 7. Right. So if y is that, now if y is odd, I'm not going to do this kind of calculation. All I know is an odd number cubed will be odd. Odd times odd times odd. That's what we said earlier on. Odd number cubed. So this whole thing will be odd in this case. So 125 is odd. But 125y cubed, I'm sorry, y cubed is odd. Right? So 125 times an odd number must end in 5. You see, this is a multiple of 5 here. If you multiply 125 by an even number, it'll end in 0. But if you multiply it, actually, that's much easier. I could have said 125, I should have said 125 times an even number ends in 0. That's much easier. Let's do it like that. 125 times even ends in 0. And 125 times odd ends in 5. Any multiple of 5 must end in 5. So therefore, you got 2017 plus something which ends in 0, or it ends in 5, in which case this thing ends in 2. So whether it's even or odd, the ending will always be 7 or 2, and it's not any of, a square cannot end in 7 or 2. So x squared. So we write it like this. If there is a solution, then x squared ends in 7, that is if your y is even, or 2, and that is impossible. A square cannot end in that. So that is if there is a solution. So if there is a solution, they ask you how many solutions are there. We say if there is a solution, you can get to an impossible solution. So therefore, there are no solutions. Which means that how many integer solutions are there? The answer is 0. There are no integer solutions. All right, so you can think about that. Now, I've just got 4 minutes left, and I've decided what I'm going to do is the next session, I'm going to start with where I left off here. All right, so let me just see. We went very slowly because I thought you guys were juniors. And then the other thing is, oh, sorry. Oh my God. Okay, so I'm sorry about that. So what we're going to do the next time is, I just want to do one more. Just one moment. This will take too long. Okay, I'll do this one, which is the second last one. That wouldn't take too long. Here the question is, how many integers are larger than 2,000? This is a huge monster of a number. So you got 4 monsters here. I said no calculators, right? Which is larger than the first number and smaller than the second number. So how do we do this? Now, if you look at these 4 numbers, they're all hovering around something. They all start with 2024, 20 actually. They all start with 2024, 20. So it gives you some idea as to what's going on here. So they all start with this thing here. The only thing is they differ by, you got 13 here, you got 35 here, and here you got 24 here. So what I'm going to do is actually, I'm going to give a name to one of these monsters. And I'm going to choose a monster, a number, which is maybe halfway in between here. Right? The number which is halfway in between this, I'm going to give it a name. I'm going to say, let x be equal to, or let's make it this. Let x be equal to 2024, 2024. Right? And you want to know what is this minus, what is the difference between these two numbers? So you will have 2024, 2013 times the other thing minus x squared, because this is your x. I want to know how much larger is this than that. Then we will know the answer to the question. So now I've replaced this big number by x. Now, what will this be? If x is this, then this will be x minus 11. Because it's 2000, this 2024 minus 11 gives you 2013. now you're multiplying this by that, right? Which is 2000 2035. So this is x plus 11. Because 24 plus 11 is 35. So here you get x plus 11 minus x squared. Now you see, you destroyed all these huge monsters of numbers without having to use a calculator. We just put a symbol x there. Nothing prevents us from doing that. And this is very easy to calculate. When you work this thing out, expand it. Those of you who know about the difference of two squares, this is x minus 11 into x plus 11. Well, you all should know about that because you are seniors. And you get minus 121. So therefore, this is the smaller number. This is smaller because this minus this is a negative quantity. So the difference between these two numbers is 121. So it's like, for instance, the numbers are 1 and 122. So you want to know how many are larger than this and smaller than this, right? So I'm just saying that I'll take two numbers whose difference is 121 and I count how many there are which are larger than this and smaller than this. Now altogether here there are 122 numbers. If you include the smallest and the largest. But for it to be larger than this and smaller than this, you have to remove those two. So you get 120. See? So the 120 numbers between this number, that number. And now you see, this is another trick here. It's a strategy to solve this kind of a problem. Just give a symbol to this, so something, and the algebra is much easier than to work with all these terrible, horrible numbers. Otherwise, you have to multiply the numbers. It's almost impossible to, not almost impossible. When you do it by hand, it'll take you half a day to do this thing. Chances are you get it wrong because you're going to count 120 numbers also. All right, so we're going to stop there. Next week, I'm going to do those remaining problems and try not to accumulate too many. But there will come a time when I'm going to just say, okay, you have to do the rest on your own. But the other thing is you've got tutors and you've got your supervisor, and you can try this thing out and go to your tutors. David, you want to tell them something about the tutors?
Yes, I did share the contact details with all the learners of the center managers. And then the
Right.
center managers will introduce them to the tutors.
Now, those tutors will be able to help you to solve the problems which I didn't solve. But if they are a bit too difficult, then I will do it. So I think in future, I'll have to try to tackle the difficult problems first. And whatever is left, I can leave it to the tutors and so on. But for the time being, the next time, I'm going to try some of these problems and get them over and done with. Okay, so thank you very much for being here, and all the best for your first tutorial problem, your first assignment problem. Okay, thank you. Bye. David, can I sign off, David?
Prof?
Can I sign off now?
Yes, if there's no question.
Oh, yes, sorry. Yeah,
Sorry,
okay.
they can
Yeah, I said
ask.
I'm going to allow questions. Are there any questions? There are many in the chat group. Let me just have a look at what the chat is saying. Savage, okay, Savage Reed, he's one of our organizers. Yes, it is going to be recorded, and he's quite happy with that. Okay, somebody said we will have 5 pairs of even numbers. That's excellent. That's Lesogo Makoba. He did very well. He answered that question. And
Greetings, sir.
Yeah, let me just go to the top. Ellie and Marisa read AI and so on and so forth and so forth. Let me see if there are any questions here. Oh, yeah, somebody said we cannot hear you. That was 5:20. I hope they. Oh, Darshani also couldn't hear me. Some people said they can hear. I don't know what the problem was. So, so Nasra says, Nasra, are you still there, Nasra? Nasra, are you still there? Nasra Ali Musa? All right, she's gone. Or he or she is gone. They left a question here and they left. Okay, so Samsung, are you there? Somebody called Samsung SM8245F. I don't know, this is a strange name, but that's the name that we've got here. Are you still there? All right, that person is not here. So I'm gonna get to the next one. Somebody else said I can't understand. Shlubi Pride, are you there? All right, that person is not there. Samsung has to go back to question 2. Samsung, he asked 3 or 4 questions and then he bolted. So what is the point of asking a question if you're not interested in the answer? One person said the answer is no, believe it or not. 1 out of 10. Okay. All right. So I think that takes care of it. At the beginning of the next session, David,
Prof,
I think we'll tell them.
I can see Lesego Makhoba wanted to ask something. You can unmute yourself, Lesego, and ask.
All right. Okay.
Lesego?
Okay, I wanted
Lesoko?
to ask. Yes, sir.
Yeah, ask your question, Lesoko.
I overheard you talking about a math book, something like an Olympiad group or a collection of 1,000 math problems. And to me,
Yes.
really sounded interesting. So I was asking if, like, do you know where I could buy it or how I could get access to it?
David, you're lucky because David is our salesman. He's right here.
Yes, yes, Lesego. I will first discuss with Prof, and then after that, I will answer you. I will tell you how are we going to distribute the book,
The next time,
are
just
you going
remember,
to buy
make a note
it?
of that, David. So next time when we meet, you can tell them about the book and how to get it. Okay.
Yes.
All right. Okay then. Any other questions? All right. Okay then. Thanks, David. It was a little bit erratic today because I only knew at 20 to 5 or something that I'm doing the seniors. And somehow I sort of worked through this thing. It went a little bit slow.